I'm going to go over question 2 now, which is dot. Let me share my screen. All right, so let's just take a look at this problem. So first of all, the base of the problem lies on something similar to Agarrio. Basically, if you have a dot and you can eat like any dot of a smaller size. And it's asking you that like first of all, what's the least amount of dots possible that you can eat to become the biggest dot? Or second of all, like is it and like if you can't become the biggest dot, then just like return -1. So first of all, you have to figure out like if you can become the biggest dot, and then second of all, you have to figure out like the least amount of other dots to eat to become the biggest dots, to become the biggest dot. Blah. So let's think about this. So let me add a new page. So over here, let's say we have a dot of like size like A, let's say size A, right? And then you have a bunch of other dots of like size B1, B2, B3, dot dot dot, Bn. These are just going to be the sizes of each dot. So basically, what we can do is, for example, we want to find the least. Let's assume that we can become the biggest dot, right? That we want to do is to find the greatest dot, like the greatest size, smaller than like your current dot size, and then eat that. So for example, let's say like A is between B1 and B2, like between B2 and B3. Let's say it's between these two. Then you'd want to eat B2 first. Let's say like by the way this list is ordered for simplicity. So then your new size would be A plus B2, right? And then let's say like next of all, let me just write B4, B5. Let's say next of all, your dot size is between B4 and B5, right? After you eat B2. So then you want to eat B4, right? So like A plus B2, then your new size would be A plus B2 plus B4. And you can just keep doing this. But there's a small issue that arises. It's, for example, let's say you have this, sorry, A plus B2 plus B4. But the thing is, what if this still isn't greater than B5? Then we have to add the next largest dot plus B3, right? And then if this still isn't greater than B5, then we have to add B1. And if that still isn't greater than B5, then it's not possible to become the biggest dot. So in that sense, what we're going to do is just, we're going to kind of like run through this process. Like we're going to write an algorithm just to like go through this process dot by dot. So we just search for the the largest remaining dot less than your current dot size, and then add that. Because you know this has to be optimal. Because like again, eating a bigger dot is more preferable to eating a smaller dot, of course. If you want to find the least amount of dots. So let's go through this process. So let me start typing public class dot public static void main string r. So let's just start. So scanner input equals new scanner system dot in. Then first of all we input C. First line will contain C. So let's just do that. And C equals input.next int. And then then there's going to be C input cases next. So we will iterate through these. Now for each input case, first of all, we take in S, which is the initial size of your dot. So int size equals, actually, because we're going to be adding like the sizes of other dots to our initial size, let's just make this a login case. Don't want to deal with overflow issues. Input.next long. Then we input n, a number of other dots. So n equals input.next int. Now, next of all, the next n lines follow with the ith line containing a single positive integer representing the size of one dot. So just like, for example, 268 are the size of the dots. So basically what this means is that we can just create an array list to contain the size of the dots. And we're going to be using an array list instead of an array because when we eat a dot, we kind of just want to remove it from our set of dots because it doesn't exist anymore. And then so then we can continue binary searching. If we have an array, we can't really do that. But with an array list, it's really easy just to remove it. So just create an array list. Array list long. What should I call this? Let's see. I'm not creative. So dots equals new array list long. Now the next and lines we're going to be inputting the sizes of these. So dots dot add input dot next long. Okay, and then now we have to just sort this because again in our algorithm and like the process we run through, we assume that this is already sorted. All right, now let's run this actual process. So first of all, we should define a few variables to keep track of. So let's say okay, so we want a count variable for the number of dots we've eaten so far. So let's just let int count equals 0. Then we also want, then I think, honestly, that's probably, all right, so let's just start going with this while loop then. So this is going to be a while loop because like there's two conditions to the stoppage of this while loop. First of all, if your current dot size is greater than the largest other dot size. Second of all, if you can't eat any more dots, but yours isn't greater than the current largest dot size. Because that either means that, first of all, like you've completed it, like you found the count that you want to return if your dot's the greatest size, or second of all, you just return -1 because your dot, it's impossible for your dot to be the greatest size. So let's just do while size is less than or equal to dots.get dots.size dots.get dots.size -1. So what this does is it just says that if you're not the largest dot, then we just keep going through. We just keep iterating. Then what we want to do is first of all binary search for like where your dot would be in this array. So then you can find out the largest dot you can actually eat. So let's just say int place equals collections dot binary search dot size. So yeah, this just finds like where your dot would be. So basically, let's just also do if place is less than 0, place equals minus place -1. If you don't recall what this means, it just means that if place is less than 0, which just means if your value is not actually in the array, but like for example between two members of the array, then just doing minus place -1 would indicate which position your dot would actually be in if it was in the array. So for example, in the beginning, if A is between B2 and B3, then and like this would be like index 0, 1, 2, then minus place -1 would just be equal to 2. So what this means is in that case, if when you get 2, you know you can eat dots with indices 0 and 1. Similarly, if you actually find 2, like if place is actually 2 in this initial thing and place is not less than 0, that means that A would be equal to B3 initially, but you can only eat dots strictly smaller than you. So again, you can only eat dots 0 and 1. So this basically says we can eat all the dots from dot 0 to dot place -1. And we want to eat dots place -1. That's the best possible thing. So first of all, let's say if the current size is less than or equal to the smallest, less than or equal to the smallest dot remaining, then like of course it isn't really possible for you to get the greatest possible, it isn't really possible for you to be greater than the greatest possible dot because you're already stuck, and from this condition, you are not the biggest dot. What this means is we just have to system.out.println -1. I don't need a string, but it's whatever. And then we just break. Else, what this means is that this would just mean that also, by the way, we're gonna do sizes less than or equal to dots get 0 because let's say the dots are the dot sizes are 100, 100, 100, 100, 100. And then your current dot size is also 100. You might get, for example, 2 or 3 for place. And instead, and then it would start running through the algorithm and return either an error or an incorrect answer. That's not what we want to see. So we're just doing this to make sure that it's equivalent to dots get 0. So the smallest element. Now let's say that if this isn't the case, then we know that first of all place has to be greater than 0. So then we can just first of all make our dot size greater. So dot plus equals dots dot get place -1. We can also, and then since we eat this dot, which is the largest dot smaller than us, then we just remove that dot from the array list. And then finally, we have to increase the number of dots the count of the number of dots we've eaten so far, because again, that's one thing we'll have to return. So then, basically we should also introduce a Boolean, because basically this is going to be our entire loop, right? So when we're done with this, we should just print out count. But the thing is, let's say we just go through this, right, and then break out of the loop. Then we don't want to print out count. So let's just create a Boolean fin equals false. Then fin would be equal to true here. And so if fin is false, which means that we don't go through this portion at all, and instead our dot actually becomes the greatest dot at one point, and we just print count and we're done. Because again, count represents the number of dots we've eaten. So again, this is going to be this is pretty obviously the optimal algorithm because we just eat the greatest possible dot we can. So let's just run this, see if it works. And surprise, it does. So let's submit the code. And yep, all 3 test cases are accepted. So yeah, that's the problem.